Hello everyone, welcome to our YouTube channel R Square Pathshala. My name is Ravi Sani. In the previous video, we had started our 6th class NCRT book, The Earth, Our Habitat, and learned about the first chapter, that is the Earth in the solar system. In this video, we will be learning about chapter 2, that is latitudes and longitudes. But before starting with this chapter, let us take a recap of what we have learned in the previous lecture. In the previous lecture, we had learned about solar system, we had learned about celestial bodies, we have learned about stars. Stars were those celestial bodies which have their own heat and light and emit in large amounts. Those were called stars. Now some of the celestial bodies which do not have their own heat and light and are lit by the lights of other stars were called planets. Then we had learned about constellation. Ursa Major was one such constellation. Then we have seen the position of pole star. Yeah, how in ancient time people used to determine the direction using the pole star. Then we have learnt about solar system, the sun, 8 planets, satellites, and some other celestial bodies like asteroids and meteoroids. Then we have seen the names of the planet, uh, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Then we have briefly learnt about Earth, which is also called a blue planet, and Earth has favorable condition to support the life, and which other planet do not have. Then we have learnt about Moon, then asteroids, meteoroids. Meteoroids were small pieces of rocks which move around the sun. Then we have learnt about galaxy. Our solar system is part of Milky Way galaxy. Okay, so that was all we have learnt about in the previous lecture. Now in this video we'll be knowing latitudes and longitudes. Let's start. So, as we all know, as we also learnt in the previous chapter, that our Earth is not a sphere. It is slightly flattened at the north and the south poles and bulge in the middle. Like if I draw a rough figure, it is like this, slightly flattened at the north and south pole and bulge at the center. This shape is geoid type shape. Okay. So what is globe? Globe is a true model, a miniature form of the earth. Like in this figure we can see the globe. This is miniature form of globe. Okay, so globes may be of varying sizes and types. Big ones which cannot be carried easily, small pocket globes, and globe like balloons which can be inflated and are handy and carried with ease. So globe is not fixed, it can be rotated the same way as a top spin or a potter's wheel is rotated. On the globe, countries, continents, and oceans are shown in their correct size. Often in the classroom, we have seen the globes. So on that globe, if you have noticed, then there are countries are shown on the globe, continents are shown on the globe, and the ocean are shown on the globe. All these features are shown according to the correct size or according to the scale. So it is difficult to describe the location of a point on the sphere like the earth. So we need some reference point about which we can define a position of a place, a position of a city, a position of a country, or any other place. So Now the question arises as to how to locate a place on it. So as I have told, we need certain points of reference or lines to find out the location of places. So in this globe, we can see a needle is fixed. Needle is fixed through the globe in a tilted manner, like from here to here a needle is fixed. Okay, needle is fixed. So this needle we can call it as its axis of a globe. Okay, 2 points on the globe, these 2 points, one point and the second point through which this needle passes are called two poles. This upper one is north pole and this lower pole is south pole. Okay, the 2 points through which needle passes are called two poles. This is north pole and this is south pole. Now the globe can be moved around this needle from west to east, just as the earth moves from west to east. But there is a difference. In the globe there is a needle which passes through two poles, but in actual earth, in the real earth, there is no such needle, and this needle is an imaginary line in the real earth. The imaginary line about which the earth rotates. Okay, now here needle in the globe is equal to imaginary line in the real earth. Now another imaginary line running on the globe divides it into two equal parts. Like if we can see in this figure, this dotted one which we call at equator, this is an imaginary line. Or if just I simply draw a 2D diagram of earth, this line, this is imaginary line which divides the earth into two equal parts. This line is known as equator. So this northern half is known as northern hemisphere and this southern half is known as southern hemisphere. Clear? So there are two imaginary line. One is about which the earth rotates and the second which divides earth into two equal parts, which we call it northern hemisphere, which is the part which is north of the equator, northern hemisphere. The part which is south of the equator is called southern hemisphere. So these both are equal halves. Okay, now this as we can see in this figure, the equator is an imaginary circular line and is also a very important reference point to locate places on the earth. All we are learning is about how to locate a particular point on the globe. So first reference is this horizontal line or this imaginary line which we call as equator. Now all parallel circles from the equator up to the poles are called parallels of latitudes. If you can see in this figure, this is 20-degree line, 20-degree circle, this is 40-degree circle, this is 60 degree, this is 80 degrees. Similarly in southern hemisphere we have 20 degrees south, 40 degrees south, 60, 80 and then 90. These lines are called, these are also imaginary lines and are called parallels of latitude. Okay, we have divided these imaginary line. Okay, so we call these parallels of latitudes. These are measured in the degrees. Okay, so equator represents 0-degree latitude as it passes from the center. It is 0-degree latitudes. So the distance from the equator to either of the poles is 1/4. Either of the poles from here, so this is our equator, from this to this distance is 1/4 of a circle. This is 1/4 of a circle. We have to measure from here to here. This is quarter of a circle. 1/4, 2, 3, 4. This is one quarter. So 90 degree. So the distance from the equator to either of the pole is 1/4 of a circle. It will measure 1/4 of 360 degree, 90 degree, as I have told. This is 90 degree. So thus 90 degree north latitude marks the north pole. This is the north pole. This is 90 degree north, and 90 degree south latitude marks the south pole. So this 90 degree north, 90 degree north is north pole. Similarly 90 degree south is south pole. So all such parallels north of the equator, all such parallels north of the equator are called north latitude. I have already told that all parallels of latitude north of equator are called north latitude. Similarly, all parallels south of the equator are called south latitudes. Clear? Then the value of each latitude is therefore followed by either the word north or south, generally with the letter N and S. Suppose here is a line. So this line we want to represent. Suppose this line represents 20 degree. So since this line is north of the equator, we can define it as 20 degree north. 20 degree north. Suppose there is one more line. This is 30 degree, and we know it is in the north, so we can denote it as 30 degree north. Similarly, if in the south this line suppose 10 degree, so we can define it as 10 degree south. Similarly 20 degree south. Okay, for example, for better clarity, the places Chandrapur in Maharashtra and Belo Horizonte in Brazil, which is in South America, are located on the parallels of 20 degree latitude. Now if we say it is located on the 20 degree latitude, we will not be able to tell whether both lie on the north of equator or the south of equator until and unless there is if it is not suffixed by letter north or south. So Chandrapur in Maharashtra is 20 degree north of equator, and later, which is Belo Horizonte, is 20 degrees south of it. So one is north of it, one is south of it, but to locate their position we have to denote like 20 degree north or 20 degree south. So like in the way 20 degree north latitude is where Chandrapur is located, and 20 degree south is where our Belo Horizonte is located. Okay, now important parallels of latitude. So the whole the parallels of latitude, this is our equator, and we have some important parallels of latitude which we must know about. So equator is our 0 degree latitude, north pole is 90 degree, similarly south pole is 90 degree south. So this line represents 23.5 degree north. This line is called Tropic of Cancer. Similarly 23.5 degree south line is called Tropic of Capricorn. Now the area between Tropic of Cancer and Tropic of Capricorn is known as torrid zone. Okay, let us first learn about the parallels of latitude, then we will be will discuss about the zones. These are basically heat zones we will be learning after this topic. Okay, so we have learned about 0 degree latitude is equator, 23.5 degree north Tropic of Cancer, 23.5 degree south Tropic of Capricorn. Then we have Arctic Circle, which is 66.5 degree north Arctic Circle. This line similarly we have 66.5 degrees south Antarctic line. Okay, and we have already discussed 90-degree north is North Pole, 90-degree south is our South Pole. Okay, now let us discuss about heat zones. What are heat zones? So torrid zone, we have our torrid zone, we have temperate zone, and then we have frigid zone. These zones are defined based on the sunlight available in these areas. So the area between the Tropic of Cancer and the Tropic of Capricorn is called torrid zone. Torrid zone. In this zone, the midday sun is exactly overhead at least once a year on all latitude in between the Tropics of Cancer and Tropic of Capricorn. And sun will be exactly overhead at least once a year in this zone. So this zone is torrid zone. Then beyond these latitudes, beyond Tropic of Cancer towards north and beyond Tropic of Capricorn towards south, the midday sun never shines overhead on any latitude beyond these circles. Okay, so such areas bounded by the Tropic of Cancer and the Arctic Circle in the northern hemisphere. Tropic of Cancer and Arctic Circle in the northern hemisphere. Let me change the color. This area and this area. In the north between Tropic of Cancer and Arctic Circle, in the south between Tropic of Capricorn and Antarctic Circle. This area is known as temperate zone. Okay. Then areas lying beyond Arctic Circle in the northern hemisphere and Antarctic Circle in the southern hemisphere. This zone and this zone. Beyond Arctic Circle in the northern hemisphere, beyond Antarctic Circle in the southern hemisphere are called frigid zone. They are very cold. Why? Because sun does not rise much above the horizon. Therefore, its rays are always slanting and provides less heat. Okay, if we see this figure, this will be the position of torrid zone. This is sun, this is a Tropic of Cancer, this is Tropic of Capricorn. This we can compare with torrid zone, and this we can compare it with temperate zone. Okay, temperate zone. Then we got our first reference point, that is latitude. So for locating any point on the globe, we will be needing two reference lines. One we have learnt about, that is called latitude. Second is longitudes. So we'll be learning about longitudes in this video. So as this we have already discussed. So to fix the position of a place, it is necessary to know something more than latitude of that place. As we have seen the example of a place in Maharashtra and a place in Brazil, both were on the same latitude, but one was in northern hemisphere and other was in southern hemisphere. So that is with respect to vertical, whether it is northern hemisphere or southern hemisphere. But what about east-west extent, where the place lies? So for example, Tonga. Tonga Island in the Pacific Ocean and Mauritius Island in the Indian Ocean are on the same latitude, that is 20 degrees south, but both are miles away from each other. So how do we locate them precisely? So we must find out how far east or west these places are from a given line of reference. So basically we will be needing one reference line in vertical reference line, which we call meridian of longitudes. So the lines running from north pole to south pole, these lines of reference are called meridians of longitudes. As we can see in the figure, these lines run from north pole to south pole. They emerge from north pole or they diminish at south pole. Basically they meet at the poles. Okay, so these imaginary lines are known as meridians of longitudes, and the distance between them are measured in degree of longitude, as we have seen in case of latitude. In that case also the difference between the lines was measured in degree. Similar is here, the different distance between them is measured in degree of longitude. So each degree is further divided into minutes and minutes into second. This we will be discussing in detail when we'll be learning about time zones. Okay, so these are all semicircles and the distance between them decreases steadily polewards until it becomes zero at the poles where all the meridians meet. So this is approximate. If I draw, this is approximate equator. So if we see the distance between these two meridians of longitude, distance is more. As these lines moves towards pole, the distance between these two meridians of longitude reduces and it becomes zero at pole. This is what it is written here. Okay, unlike parallels of latitude, all the meridians are of equal length. See here, this is parallels of latitude, they have equal distance. But in case of meridian of longitude, the maximum distance is at equator and zero at the pole. Okay, so thus it was difficult to number the meridians. Hence all countries decided that the count should begin from the meridian which passed through Greenwich, where the British Royal Observatory is located. So that meridian is called prime meridian, or its value is 0° longitude. This line passes through Greenwich, where British Royal Observatory is located. So this imaginary line which passes through Greenwich is prime meridian, which means it is the reference point or 0° meridian or 0° longitude. Okay, and from it we can count 180° eastward as well as 180° westward. So prime meridian and 180° meridian divide the earth into two equal halves. So this is 0° meridian and opposite of that is 180° meridian. So these two lines divide the earth into two equal halves. Eastern side is eastern hemisphere, and then the western side is western hemisphere. Like we have seen in case of equator, one is northern hemisphere, one is southern hemisphere. So latitude divides the earth into two equal halves, one northern hemisphere, second southern hemisphere. Similarly, prime meridian and 180° meridian divides the earth into two equal halves. So one is eastern hemisphere and one is western hemisphere. Okay, similarly the longitude of a place followed by letter E for the east and W for the west. For any meridian which is on the east side of prime meridian, it will be followed by the degree and the letter E. Similarly, a place on the west of prime meridian will be followed by west, W. However, interesting to note that 180-degree east and 180-degree west meridians are on the same line. Now look at the grid of parallels of latitude and meridians of longitude on the globe. You can locate any point on the globe very easily. Suppose if you are given a point that say 20-degree north and 30-degree east. So this is equator. Suppose this is 20-degree line, this is 40-degree line. For 20-degree north, 40-degree north. So from this equator, this is my 20-degree north line, and from the longitude I can see it is 30-degree east. So this is 30-degree east. So this is 20-degree and this is 30-degree. So this is my point. This is how we use latitude and longitude to determine the position of a place on the globe. Okay, you can try calculating the location using grid pattern. Suppose they have made a grid that represent horizontal line represents the latitude A, B, C, D, E. These represents degrees. Suppose this is all in so these horizontal line represents latitudes, and this vertical line represents 1 2 3 represents meridians of longitude. If you can easily find out the position of A, B, C, D, E. So this A is B degree north and 1 degree east if it is on the eastern side of prime meridian. Okay, so I hope this concept of latitude and longitude is clear to you. If you face any difficulty, then please post me in the comment section. I will try to answer as soon as possible. Now, how do we use this latitude and longitude to determine the time of a place? So let us learn about this, and this is the last topic of this chapter. So let us learn about this quickly. So the best means of measuring time is by the movement of Earth, Moon, and the planets. The sun rises and sets every day. Naturally, it is the best timekeeper throughout the world. And the local time can be reckoned by the shadow cast by the sun. As we have seen in the torrid zone, in this zone, if I show you in the graph, in this zone, sun will be overhead at least once a year. So from this we can see the shadow cast by the sun, which is shortest at the noon and the longest at sunrise and sunset. So from this we can fix the time accordingly. Let us see how. When the prime meridian of Greenwich has the sun at the highest point in the sky, all places along this meridian will have midday noon. Means this is my prime meridian. So when sun is on the highest point on this longitude, so all the places along this longitude will have same time. Correct? As the earth rotates from west to east, those places east of Greenwich will be ahead of Greenwich time, and those places to the west of it will be behind it. Okay, let me show you this in a picture. So this is my Greenwich line. Okay, Just a second. This is my Greenwich line. Okay, your Greenwich meridian. This is east side of Greenwich line, and this is west side of Greenwich line. All the places east of this line will be ahead of the Greenwich line, and all the places to the west of this will be behind the time. Suppose, as because earth moves in west to east direction, sun will rise from here, so obviously this point will be the area where sun rises, sun will rise first at this point. Okay, so if this is 0, as we move from this to this side, time will be ahead, and from this side time will be behind. We will see how it will be calculated. Just a second. Just a second. Yes, so as we have seen, from the prime meridian, this is a prime meridian, this is 180 degree east, 180 degree west. Okay, so this is total 360 degree, so the rate of difference can be calculated as follows. The earth rotates 360 in about 24 hours. Okay, so which means 15 degree an hour means 360 degree divided by 24, so it comes out to be 15 degree per hour. Okay, and 1 degree in 4 minutes. So when it is 12 noon at Greenwich, the time at 15 degree east of Greenwich will be 15 into 4 equal to 60 minutes. Means if any line which is 15 degree east, it will be 60 minutes ahead of Greenwich time, which means 1 hour ahead of Greenwich time, which means 1 p.m. But at 15 degree west of Greenwich, the time will be behind Greenwich time by 1 hour. It will be 11 a.m. Similarly, at 180 degree, it will be midnight when it is 12 degree noon at the Greenwich time. Let me explain this once again. This is my earth. Okay, this is my prime meridian or 0 degree meridian. Suppose it is noon or 12 p.m. at Greenwich meridian. This is one meridian which is 15 degree east, and this one meridian which is 15 degree west. As we know, earth completes its revolution in Earth rotates about its axis in 24 hours. So in 24 hours, Earth rotates 360 degree. So in 1 hour, Earth rotates 360 divided by 24, that is 15 degree. So in 1 hour, Earth rotates about 15 degree. As Earth moves from west to east, when it is 12 p.m. at noon, time on the 15 degree east longitude will be 12 p.m. plus 1 p.m. At the same time, time on the 15 degree west will be 11 a.m. As we have learned, from the Greenwich line, as we move towards east, the time is ahead of Greenwich time, and if we move west, time is behind Greenwich time. Okay, now why do we have standard time? So the local time of places which are on different meridians are bound to differ, because as we have seen, with each 15 degree of meridian there is a difference of 1 hour. Okay, so for example, it will be very difficult to prepare a timetable for trains which crosses several longitudes. So suppose if one train has to move from this to this, so it will crosses several longitudes, and from each longitudes there will be different times, so it will be difficult to prepare a timetable for a train. So in India, for instance, there will be a difference of about 1 hour and 45 minutes in the local times of Dwarka in Gujarat and Dibrugarh in Assam. From this point to this point, there is a time difference of 1 hour and 45 minutes due to its longitudinal extent. So it is therefore necessary to adopt the local time of some central meridian of a country as the standard meridian for the country. So we have adopted this. Our longitudinal extent is from 68 degree east to 97 degree east. So we have adopted a mid meridian which is 82.5 degree east as the standard meridian of for India. So according to this, we are 82 degree and 30 minutes east. This is a standard meridian for time calculation. So the local time at this meridian is taken as standard time for the whole country. So this is known as Indian Standard Time. Okay, now our standard meridian for India is 82.5 degree, and we know Greenwich, it is 0 degree. Let me draw one circle again. This is standard meridian, this is a India, suppose. Sorry for the figure, I'm just giving you a feel. So this is 82.5 degree east, and this is 0 degree Greenwich meridian. So as we know, for each 15 degree there is a time difference of 1 hour. So calculate the time difference between Greenwich Mean Time and the Indian Standard Time. So what we'll do, we'll simply divide this longitudinal extent to 15 degree. So it will come out near 5 hour and 30 minutes. So when it is 12 p.m. here it will be plus 12 plus 5.3 hour, mean 12 hour 30 minutes, which is ahead of Greenwich time. So it will be 5:30 p.m. in India. Okay, Hope this chapter or this topic of latitude and longitude is clear to you, and you try to find out the time using a random longitude in east and west direction, or try to solve these questions which are given at the end of this chapter. Solving these questions will give you more clarity about the topic. Hope you like the video. So thank you very much. See you in the next video, where we will be discussing about motion of the earth. Thank you very much.